Who is
It's Sapura. By mistake, we have.
okay. All right, class. So in the last class, we had started with gravitation and the basic formula law of gravitation we could cover along with the superposition principle. So see, firstly, this formula is very important to all of you. I hope I'm audible to all of you, those who have joined right now as well. Okay. So yes, this formula is very important because this lesson is, though it's an easy lesson, questions that you will get, the questions will be easier than the questions of rotation. All right, class. But this is an important lesson with respect to your class 12. In your class 12, just immediately, when you will enter class 12, the lesson that will be starting, electrostatics and all, that will be very similar to this part. Otherwise, since all of you, this session also started late, so at this moment in the month of December, we are covering this quite late. So you will be able to remember it till the month of April and March, whenever you have to have your exams. Otherwise, it happens before 11, 12 starts. These lessons are usually covered in August and also we all forget. But right now for you all, it's easier to remember. So remember this gravitational formula. Terim, one more thing. Terim, do you have your maths class on Sundays as well?
Yes, ma'am. It's around like India ke 9:30.
India ke 9:30. So duration क्या होती है?
1.5 hours.
1.5 hours. Okay, so both the days you are having it. Saturday, Sunday, दोनों दिन?
Yes, ma'am. Dono.
Okay, because I didn't know about your timing, so that's why I didn't take the class on Friday. I was not well on Friday. So I was planning to take your classes on Saturdays and Sundays, but then I got to know about other students are, I think, also having their maths classes. And some of you, do you take those self-study sessions that are happening here? Anyone from this batch? Self-study classes are there, no? Okay, no one, I think, from here. Fine, then we'll have the class then Friday. This Friday only we'll have the class, because other days I think you people are also not available. Rest of the time I am not available. Okay. Anyways, so gravitational force was what? Capital G, that was the universal gravitational constant, mass, product of the. Basically, this law said what? That gravitational force is directly proportional to product of the masses, that is M1, M2, if two bodies are present. Also, it is inversely proportional to the square of distance. And the constant that we use it's a universal constant. That means for every planet anywhere you can apply it. Then we came to gravity. Gravity is the specific name given to the gravitational pull of Earth specifically, if you refer it to. Right. And acceleration due to gravity came out to be capital G into capital M by R square. Now see, this acceleration due to gravity, this value is fixed, 9.8 meter per second square. But this is exactly at the surface of Earth. What if I vary the height? Let me take the body that is kept on the Earth. If I bring it to a certain distance, to some height, then acceleration due to gravity. See here, this R will be variable now, because now just the radius is not present. Along with the radius of Earth, we have this additional height now. So obviously this will affect the acceleration due to gravity, because acceleration due to gravity is nothing. Every property is exactly that of acceleration, and you know how acceleration varies with which quantities. So that we have to see. Then we did superposition principle. So firstly, let us start with what I was mentioning, variation of acceleration due to gravity. So variation of acceleration due to gravity, that is G. Now let us see with height, variation due to height h. It means, let's take see, if this is Earth, the body is kept here initially at this point, exactly at the surface, where you get capital G into capital M by capital R squared, GM by R squared. But if I bring this to a certain height h, then see class, total distance will be h plus R. H is the height. This is some height, random height. And capital R is the radius of Earth, right? So now if you take acceleration, let's name this as small r. So now if you write the formula, this will be gm by small r square. Small r square here does not mean capital R. Capital R is the radius, small r is r plus h. That will be r plus h whole square, capital G into capital M by r plus h whole square. So here you can see this also varies inversely proportionally only. But now see, here if I take r square common, just focus on the denominator right now. If I take r square common, I'll be left with 1 plus h by r. This whole term, this entire term square. Understood? Now see, this is some g dash because this is not our g. R is changing, so g dash is also changing. But now see class, if you look up here, gm by capital R square. This was exactly g, that was gm by R square. So the variation of acceleration due to gravity, look here class, g dash will be equal to small g. Then you have the term 1 plus h by R whole square. This term you have it. Now see, let's not even keep it till here. If we use binomial expression to simplify it further so that we prevent this denominator thing. So if you use binomial expression, so see 1 plus x to the power n you have, this is 1 plus nx. This is 1 plus nx, binomial expression. Those who have mathematics, you all will be studying this in detail, or you must have studied this in detail. So if you apply, this is 1 plus x to the power n. Similarly, here it will be 1 plus h by r to the power n, and n is 2, x is h by r. So this way, this becomes 1 by h by r to the power minus 2. Now see, is it matching your binomial? 1, 1 plus x h by r to the power n to the power minus 2. And also class, one more thing, to use binomial, x is very, very less than 1. So you can use this formula when your height is very, very less than the radius of Earth. Then only you can use binomial expression part. Till the time, if the height and r both are comparable, they are not variable like this, then use this. Use this. If you see the height is very small, then come to the conclusion and write the final formula g dash is equal to g 1 minus 2h by r. This will be the variation of acceleration due to gravity. Let me tell you a question so that you get the understanding part of it. Again, I'm repeating one thing, class C. This formula g is equal to this small g, this is equal to g m by r square. This formula, this is acceleration due to gravity of Earth at the surface, whose value is 9.8 meter per second square. This value is only 9.8 meter per second square, right? This is the formula if a certain height is considered. Suppose, let's say the height is very small in comparison to the radius of Earth, then you can use this formula as well. And this formula is also mentioned to you in the exams. Let's discuss one question so that at least you'll get familiar with it. See, this says calculate the height at which value of acceleration due to gravity decreases to half its value at the surface of Earth. Means half of its value is basically, you can simply say G dash is becoming now 50% of acceleration due to gravity that was present. Fine. Now C class, here what is happening? Radius is, the acceleration due to gravity is decreasing to half of its value. If at the surface the value is G, now it will be 50% of G. Right, now it will be 50% of G. And you have to find that value. See, if you, even if you expand this, even if you solve this only, you will get 50 by 100 into G, 50% of G you are calculating. This means G m by small r square, which is equal to G by 2 now. Half of its value, exactly half of its value it is mentioning. So it will be G by 2 only. Now see, if you take up the ratio, or do one thing, multiplied by capital R square. Multiply and divide it by capital R square. So see what you will get. If you multiply and divide it by capital R square, so see this part class. G m by capital R square. This will be G. So this becomes G capital R square by small r square is equal to G by 2. Understood? G dash is now G by 2. That is what we are keeping it here. So G gets cancelled. 2r square becomes r square. So 2r square will be C. Now we are keeping the value of r. What was r? R plus h. Just for simplification, no, I was keeping it as smaller. Otherwise, you know, this is r plus h. So r plus h whole square. So r root 2 is equal to r plus h. So from here, if we take and calculate the height, what will be the height? Let's bring radius on this side. R root 2 minus r is equal to h. So height will be r root 2 minus 1. This will be the height for which acceleration due to gravity decreases to half of its value. How did I write this? C class. G is equal to Gm by capital R square. Whereas G dash is equal to Gm by small r square. And it is given that G dash is half of G by, or half of G. So from there I got this relation and I kept it and I finally got the formula for it. All right, class, note down this variation part. Any doubts you have, let me know. Yes, class. So complete it till here. Variation with acceleration due to gravity. See, the final formula that will come will be G dash is equal to G1 minus 2H by R. But see, this is the condition, then only you will be able to use this. Otherwise, see the basic formula, as I've told you, that will be G dash is equal to G divided by 1 plus H by R whole square. Now see, this was variation with height. Similarly, you will be observing variation with depth. So variation with depth. Earlier, I took the body to some altitude, H, height was there. Now I will take the body inside the earth. So let's say this is the radius R. At this particular point, I am keeping the body. So see, entire depth is, let's say the entire depth is small d. So this time the radius that will take, see earlier what we had, the radius was capital R, height was small h. So total we had h plus r, right? That small r that I used to take. Now see, this time this entire radius, this is capital R, right? And the depth that I'm taking to which the body that is going, that is small d. So class, can you tell what will be small r in this case now? Radius is r. Depth we are taking as small d. Depth, this is the depth. Let's say this is the depth, small d. What will be the portion that will be remaining?
Ma'am, R minus T.
Yes, r minus t. Correct. Capital R minus t means a capital R is what? That is the radius of Earth, and small d is the depth which we are taking. Now see acceleration due to gravity at this particular point. Name this point something. Let's say P. At this particular point, P, we are calculating the acceleration due to gravity. So G dash will be Gm by R dash, R square. Now see class, mass will also change, no? Earlier, we were considering the entire Earth. But this time we are having the area that is enclosing beneath the body that we are considering. So it means the mass will not be the mass of the entire Earth. It will be the portion that will be beneath the depth. So mass will be different, acceleration due to gravity will also change, and radius obviously will change. So as rightly answered, it was R minus G. So here also we'll keep this. This will become capital G, gravitation constant, m dash divided by R minus G whole square. This is it. Now see, m dash also we have to find out. See, right now this m dash is missing. This m dash, we cannot use it in the formula. So we have to find out the value of the mass. So see class, m dash is what? M dash is the mass of the portion which is having the radius R minus G. This radius small r, which is R minus G, that part's mass is m dash. So this is mass of portion of Earth having radius R minus G, you write, or small r you take. Let me write it R minus G so that it is clear to all of you. So that is capital R minus G. M dash is the portion for it. So mass of volume 4 by 3 pi r cube. See, entire volume. This is a sphere, Earth is a sphere. So volume if you take, so mass of this entire Earth, that is capital M, which we are not including right now. Mass of the volume of 4 by 3 pi r cube is M. This mass we are not including. We are trying to find out the mass for m dash. So see, for unit volume, this is for 4 by 3 pi r cube. If you want to find out mass for unit volume, that will be this entire term divided by this. So 4 by 3 pi capital R. So unit volume, you know, for 1 unit volume, you have the data. So now see, mass of this volume having the radius capital R minus small d. For radius R, mass was this. For unit volume, you are having this term. So if we want to find out mass for 4 by 3 pi capital R minus d whole cube, this much radius if we have with us. So just multiply it with this entire term. That will be m by 4 by 3 pi r cube multiplied by 4 by 3 pi r minus d whole cube. This is what? Simple unitary method that we have applied. And this is the mass which we are calculating, m dash. M dash was unknown to us, no? So 4 by 3 gets cancelled, pi gets cancelled. So m dash becomes equal to m r minus d by r whole cube. So now we have the value of m dash. So once you have the value of m dash, let's put it in the value of small g, which we were calculating. So this will be g m dash. So instead of m dash, now I will keep m r minus d whole cube by r cube. So g m dash has been kept, and in the denominator we had r square. So let's write it as r minus d whole square. So see class, some things are getting cancelled. R minus d whole square will cancel this cube. Only one single r minus d will be left. So see. Okay class, one more thing. Can I write r square what will be r square multiplied by r? If you just multiply r square with r cube, yes, it will be r cube, correct. So it means I can write this r cube which is present as r multiplied by r square. So this makes it gm r minus d by r square into r. Can anyone tell me what is this part? Just this part. Yes, class. Aram. Capital G multiplied by capital M divided by R square. Just this part. Are you able to recall this? Aram.
It's mm, is it gravitational potential?
Not gravitational potential, acceleration due to gravity. Small g. Small g's value, no, we had started with. This is g dash which we are calculating the variation g m dash by r square. The original acceleration due to gravity in the last class which we had seen. It was capital G into mass of Earth by square of radius of Earth. So this is the original gravitational constant. This is the variation that we are observing, right? This is the variation with depth that we are seeing. So that makes it, this entire term will become small g, and you are left with r minus d divided by r. Or even you can write for the ease of your calculation g into small r by capital R, where you know small r is depicting what? Small r is depicting simply r minus g. Otherwise, you can do one thing. G dash is g. Just separate the denominator. That is r by r minus d by r. We can write this. Same thing, r minus d by r is there. So I can separate the denominators. No, both are the same. So this cancels. So final formula is g 1 minus small d by r. So this is the formula. This is the variation of acceleration due to gravity with depth. Here small d is the depth. Whereas in the formula for height that we observed, small h was the height above the earth. This is the depth below the earth. So this was the second case. Note it down. Any doubts you have, let me know. C class, gravitation. Now the new acceleration due to gravity is given 1% of G, 1% of acceleration due to gravity at the surface. Now you have to find out the depth. It's the same method you'll apply. G dash is what? G dash is the variation with depth. This is the new acceleration due to gravity that is given. So it means this will be 1 minus d by capital R, right? And this is 1%, that is g by 100. 1% means what? Here you have 1 by 100 only. So g by 100 you have small g gets cancelled. You are left with 1 by d by R is equal to 100. So d by R will be, here you have, this will be 99 by 100. So D will be, from here if you take 99 by 100 into R, so this D becomes 0.99 R. 0.99 times the value of radius of Earth. Now radius of Earth you already know. Put in the value, get it. And see what's your answer coming. Like this you have to solve. Note it down, and all those who are getting the value, send me in the chat column. Yes, that's 1 by 100 only. So if you multiply 1 by 100 into G, that becomes G by 100. So that is 1 by 100 only.
Okay, ma'am. Ma'am, is 63360 the answer? Like 0.99 into
How much you're getting?
6,336.
6,336 after multiplication.
Yes, ma'am. 0.99 into 6,400, the radius.
Okay, and what about others? Only Tareem has calculated. Okay. Tarif, no? Tarif is what the same answer. Good. Fine. Now let's see a graph. One graph is left from this topic. Let's just complete a graph. Variation you had seen with height and depth, right? So if we plot the graph, graphical representation. graphical representation. Now see with height and depth, let's see. If you see it for height, variation of acceleration due to gravity with height. See, we had seen the formula here. C class here. This is small g, the acceleration due to gravity. This is r. So how are they proportional to each other? Directly proportional, inversely proportional, g prime and r square. Inversely proportional. Right. And if you see the variation with depth, see here. Small g, variation with r. Now directly or inversely? Is it still inversely proportional? Directly proportional. So it means when you are considering the variation with height, your acceleration due to gravity is inversely proportional to the radius. That is, g is inversely proportional to r square. Or you can say directly proportional to 1 by r square. Either directly proportional to 1 by r square or simply inversely proportional to r square. And if you see the variation with depth, then g dash is directly proportional to r. So see, if you plot a graph, so certain points I am marking. See, let's say this is exactly at the center of Earth. So small r will be 0 at the center. And at the surface, this small r will be exactly the radius of Earth. This is the surface. So it means in between this, if you are considering any portion, it means small r is less than r. This means this is inside. This is the center. This is the surface. So if you take points between the center and surface, that will be any point inside the Earth. And any point above the surface, that will be outside. So small r will be greater than capital R. This point will be outside. So see, for inside means depth. This is directly proportional. So you will get a graph like this. It will be linearly varying. If this is g prime on your y-axis and this is radius on your x-axis. So it will be linearly proportional. G is directly proportional to r. And from here, this is inversely proportional. So you will get a hyperbola. So g dash is inversely proportional to r square. So the way I was mentioning regarding this graph, the graphical representations will be exactly similar when you step up into class 12. Same things you'll have. So learn all these graphs right now only. These will be just relating to you. Instead of masses, you will be having charges, same variations. Conductors will be present instead of Earth, like this. So plotted, then one more variation we'll see. See, depth we had seen, height we had seen, rotation is left. Rotation of Earth. As the Earth rotates, acceleration due to gravity varies that way also. So that we'll see. Just note down this graph first. Done class till here? Anyone is writing, just stop me, I'll scroll up back. Now see, variation with rotation of Earth. Variation of rotation with Earth is not that important. Mostly you have questions from height and depth. So prepare thoroughly height and depth portions. Questions will be there. Rotation part also can come. From your theoretical point of view, rotation part can also come. Now see, rotation we have already completed. You know circular motion, you know angular velocities concept. So this is omega. Let's say the Earth is rotating with omega. This is the angular velocity. So it is rotating with omega. Now see, a central force, we have studied about a force that acts along the radius towards the center, centrifugal force, right? So centrifugal force will be acting towards the center. So here, while rotation, the force that we'll be considering in mind will be centrifugal force. And obviously, you know, for centrifugal force, it acts along the radius towards the center. Two conditions are necessary to identify centripetal force. And one line that you know that divides the Earth into two hemispheres, that is the equator. So here you will be considering the geography of Earth as well. So equator of Earth will be present. So due to centrifugal force, what will happen? Acceleration due to gravity will decrease. Because of this centrifugal force that will be occurring. See, acceleration due to gravity is what? It is acceleration only. So whatever properties you have studied for acceleration, simple acceleration in your laws of motions, all the properties will be valid for acceleration due to gravity. One more thing, class. We have already covered acceleration due to gravity and motion under gravity. So same phenomena are occurring here. So same thing, centrifugal force will decrease the acceleration due to gravity. Now the derivation is not a part of your syllabus. You just remember the final formula, G prime. G prime means the new acceleration due to gravity. So it will be G minus, G is what? G is the acceleration due to gravity at the surface of Earth. 9.8 meter per second we take, no. So this is that G minus R, that is the radius of Earth, omega square. Now, one thing we have that is cos square lambda. Now, what is this lambda? Lambda is the angle that is made. See, this is the radius of Earth. Let's say this is the radius of Earth. So any point you are taking with from the center of Earth to the surface, that makes your radius. And to the equator, if you take this angle, this will be lambda. So your formula becomes G dash is equal to G minus R omega square cos square lambda. Lambda is the latitude which we say. Latitudes and longitudes you must have heard in your geometries. And omega is angular velocity. Omega is every phenomena, 2 pi by t, 2 pi nu also frequency. If you write it in terms of frequency, those will be same. 2 pi by t means time period of Earth. And time period will be time period of the rotation. What is the time period of rotation of Earth? Time period of rotation of Earth. Yes, class. What will be the time period of rotation of Earth? Yes, 24 hours. No. So why did it take you so long? 24 hours. 1 day is the rotation of Earth. I'm not talking about revolution. Rotation of Earth, that will be 24 hours. So time period, T is the time period. Time periods. And the rest of the relations you already know. Omega is equal to 2 pi nu. Nu is the frequency. Omega is equal to 2 pi by t. Everything that you've studied in circular motion, those will be applied over here. Now see, the part that I was mentioning you, the types of questions that arise from this part is regarding poles and the equator. See, variation of acceleration due to gravity at the poles and at the equator. If someone is standing at this point, see here, this is the point. So it means this part, this radius part, this will be it. Now see from the equator, from this median line, what will be the angle? Can you tell what will be the value of lambda at the poles? Look here, I have mentioned here, these are the poles. So at the poles, what should be the value of lambda? Yes, Waziha? Look here. When I had taken R, this was lambda. Now, if I am bringing R over here, so this entire angle becomes Waziha. Yes, class, my screen is visible to all of you now.
No, ma'am, it's not
Is this
possible.
And now, are you able to see
Yes,
this
ma'am, the
screen,
screen is
class?
visible, but your
Yes,
voice
ma'am.
is breaking.
Okay, okay. So just saying yes at the pole. Am I audible now? Hello?
Yes, ma'am.
Okay. So see, class, from the equator, if you mark this angle will be 90°, no? This entire angle at the poles will be 90°. And if you're talking about the equator, if I'm taking this reference line at the equator only, then the angle will be so at the equator, if you take lambda's value will become 0°. So at the poles, lambda's value is 90°. At the equator, lambda's value will become 0°. C class, if this term becomes 0°, g dash, which is g minus r omega square cos square lambda. This term is 90°, so this entire term will be 0. Cos 90 is 0. So g dash becomes equal to g. So this comes from your theoretical question, as in what is the value or how is the variation of acceleration due to gravity observed when there is variation, when the latitude's value is 90°, or when an object is kept at the pole. So for poles, you have such value. And if it comes for the equator, so at the equator, lambda's value will be 0°. So g prime, which will be g minus r omega square cos square lambda. This time lambda is 0, so cos 0° is 1. It means just this term won't be there, rest of the terms will be present. So mainly questions come to differentiate between the variations at the equator and the pole. G minus g r omega square. This will be it. And this is just the variation that is observed in terms of rotation of Earth. So note it down, class. Anywhere if the screen is not visible to you, just let me know. All right, note it from you. Yes, class. All those who have completed, you all can leave now. On Wednesday, we'll continue with this. So Wednesday we'll have a 2 hours class duration. Okay, the way no on that Wednesday also we had it. So from Indian timings, it will be 7 p.m. Like today we had it from 7:30 now, so it will be 7. So for you people, it will be 4:30. Right. So 4:30 KSA timings and IST, it will be 7 p.m. 2 hours class we'll have. We'll let us just quickly sum up with gravitation at least. And you have mechanicals, book 2 to be started. All right. So any doubts if you have, you can ask me. Otherwise, let's meet on Wednesday now. Okay, class. Thank you so much. Talha, see, Indian time IST is 7 p.m. So for you, it will be 4:30.